But that's just not how it played out. So it pushed in me to sort of finish this application. And so I've definitely gotten a lot farther with it. We now have the ability not just to review a PR with AI, but we can also just point it at a file set or a series of files or one file. The AI that I have, it finds the batch bug every time without a doubt. So it is able to find that bug. It's able to find a couple others that are sort of low priority. It was able to find so much and so much interesting stuff that we're still sort of sifting through. And so I think the goal is just to get as many of these sort of AI helpers that can just sort of flag these bugs. That's definitely one of our goals.
Hey and welcome everyone to the second part of the interview series hosted by me, Krippenreiter, and my regular co-host Vet. This time again with our special guest Denis Angell from XRPL Labs. In case you missed the first part where we talked about options trading, here's a pop-up that you can click to start from the beginning. This time we will talk about his approach on AI and security and how the XRP Ledger will use AI audits to become even more secure. Also, the quantum secure AlphaNet is a topic we will cover today to learn more about quantum security for the XRP Ledger and your holdings. Without further ado, enjoy the show. AI audits is also a huge one. Like we will talk about the quantum network as well later, but right now I think AI audits are really important. From your perspective, I would really like to know more about the batch aftermath. From your point of view, what went through your mind when this all happened? Was it collapse for you, or would you say, wow, we will never... How did you run through?
Sure, yeah. So I was on vacation and I heard about it. And then we scheduled an immediate phone call with Ripple and I and multiple Ripple people. And I then received sort of like the ability. The first thing we do when we get something like this is we have to reproduce it in code with a test. So I received that and I immediately found where the bug was. And I was like, wow, this was really glaringly obvious. And then I sort of try to live by like a thing where like you acknowledge it and then you find solutions. Like that's the only real two things I think you can do in a situation is just acknowledge it and then offer solutions. And so that's what we immediately so after that we discussed it, then we made it, decided how we were going to handle it, a hot fix. And as that's going on, we sort of then started brainstorming about, what can we do? How can we make this better? Obviously, AI was the one who caught it. I had been building this AI app I've been building it for a long time. It has many different names at this point, but I had just gone on vacation. And the problem with it, the reason I wasn't using it, it's pretty expensive. We're talking about these Claude PRs being $25. Like, I ran one on 2 files and it was like $300. So it cut into my personal cost. And so I really didn't love the idea of putting this out there, or putting, my money on the line and scanning these files if it wasn't going to net anything. In retrospect, I should have pointed it at batch and escrow and then gone further and did some more things. But that's just not how it played out. So it pushed in me to sort of finish this application. And so I've definitely gotten a lot farther with it. We now have the ability not just to review a PR with AI, but we can also just point it at a file set or a series of files or one file. The AI that I have, it finds the batch bug every time without a doubt.
Nice.
So it is able to find that bug. It's able to find, a couple others that are sort of low priority, but it was able to find so much and so much interesting stuff that we're still sort of sifting through what's there. And so I think going forward, I think the plan is really multiple AI agents. We have Copilot running on all of them. Another member of Ripple created his own sort of app that can review a PR, and he's got that going as well. So, and then we have mine. And so I think the goal is just to get as many of these sort of AI helpers that can just sort of flag these bugs. That's definitely one of our goals.
On this actually, Dennis, so how is AI very concrete helping like you as a core developer or other core developers to to do these things better or identify? Like what is it doing that is so augmenting like you as a developer?
Can you maybe even show something? Like you have a demo prepared, right? Maybe
Sure,
show
yeah,
how
I can show
it works.
I can show you how it works. To answer Vet's question, I think I would say that it's got a good ability, and not that a human doesn't have the ability, but it's got a good ability to step through code. And so if it's like, okay, what is this function doing? Or what is this code right here doing? It's like, okay, well, where did that parameter come from? Okay, that came from here. Oh, and it follows it back up the stack. And not to say that a human can't do that, but a human makes mistakes. A human gets tired. A human has emotional levels. And so there's all these aspects of a human that come into play when they're tracing it up the stack and they have 50 different folders open. And you could just imagine, and I guess here'd be the good difference, is like you could imagine somebody's computer with 50 different Chrome browsers open. And you're like, how do you ingest all of that? AI can ingest all of that in a matter of seconds, and it knows, where that one is and where that one is. And that's the difference, I think, in that the human coding versus the AI is they just have this ability to go faster to where they need to be and ingest more information and keep it really up in the front. So I guess that maybe answers the question. All right, so this is the app. And when you first create an account, you have to start by creating an agent. The agent is basically the repository that everything's going to be built from. So your PRs or what you're reviewing. We create this agent, and it's an index of a specific folder set. And the index, what it allows us to do is it allows us to find folders faster or find symbols faster. And so it's just a little bit of an increase in speed. But the magic happens here in these audits. And so you can see here, this is a Ripple D path audit. The path we're auditing is the invariant check file. You can see, because this is already successfully run, we can see the files that we've actually audited. And then we can see the agents that have audited the file. And then we have some advanced stuff down here, but that's not really that important. And then when we go to our issues, we can see our issues, and we can see something here. It's an issue about a bad assignment. We have the file that it occurred in, the recommended solution. And then we have some additional details. We have this exploit scenario. And then we have whether or not it's confirmed. What we do is we have multiple agents that review these files. And so they review the file. And if they find a bug, then we actually get another agent to check whether or not that bug is valid or not. And go through and basically what I was talking about earlier, step through the code, go a little slower. Because the agent's picking up the errors, they may not have the full context and understanding of the ledger in its entirety. And so I've found that if we just do a double check, we can eliminate some false positives. Then once the issue comes in, we can validate it, which means we hit that same exact agent that validates during the process. We can hit it again. We can actually add some additional context if we have a reason why it should be valid. And we can do the same thing as marking it with a false positive. We can add our input and say like, no, this is not what it is. And then we also have the ability to fix these selected issues. And this one actually is fixed and basically created a PR this is in a private repo of myself, so just a testing environment. And then we have these 4 commits. So these were these 4 issues. So 1, 2, 3, 4. And we have these 4 issues here and the code to fix them. And so we can basically create a new PR based on a folder scan of just, in this case, just one file. So that's really where a lot of it happens. We can also go and see the create process. So we can create a PR, we can create a review or what I would call an audit from a PR, and we can actually just, choose which PR we want. And then down here below, we select which agents we want. There's 8 of them. and some of them are tied to each other. So like security and exploit, that's sort of the same agent. And that's just because the app has progressed. And at first we had 8 and now we only have 3 and they're sort of combined. We also generate a PDF report at the end.
That is cool. Like
and
you get sort of at the end like a PDF that you can look at, right, with a summary.
You could also share it, right? If it's fixed, everything's fixed, you can share it.
You could share it. I think that was one of the points I wanted. I also wanted a professional feel a little bit. So I just wanted a professional feel and the ability to be able to share that. But the real magic that we're seeing is really automatically being able to push these reviews on a PR. And then also create a new PR for like an issue we find that isn't in a PR that's sort of being merged in. And that's where I found a really big gap in the industry is that, yes, like new PRs coming in, but something interesting. And the reason why I really switched over to looking up files on their own was that lending is in like 3 or 4 PRs. And so if you review the one PR, you may find a bug that was fixed in this PR, or this PR may create a bug, but you only reviewed the main PR. And so we really now we're just pointing it at just different consensus and transactors and the ledger files themselves, so we can do just a big overview review. And that way, we know that the files that are actually in there already are already reviewed.
So Dennis, is this replacing review by core developers, or is it sort of an additional on top check that comes?
Right. Yeah, it's definitely in addition. So the process we have is you create a spec for your amendment. And then you start building it. And when you think you're finished, you need to ask for review. And so you need 2 reviewers to get it to the next step. And at that point, you're basically saying this code is done. And I think right there is where we want to introduce some of this AI stuff. We have Copilot, so that'll get a few of them. But if we have, I would say, an intermediate level, like not quite Cantina, not quite like billion-dollar company that can do AI review, but right in the middle, and not quite Claude Code, but right in the middle. And then before that user asks for reviews from senior developers, you can get that response back and you can say, oh, there was a bug here, or oh, there was this here, and fix those. And then the reviewers sort of don't have to, they aren't burdened with that bug that you found. The other thing is that we don't want the reviewers using this same technology. We really want that different side, because if the reviewers are then just going into the app and pressing review the code and it comes out good, it's not the same, right? Yeah. So we want the person's done, then they get this AI review, and then 2 reviewers review it, and then we have a final audit, a real audit from an outside company come in. Now, I would say more and more of these outside companies are using AI as well. Right. But the good thing is that the 2 components are not the same, right? We're not the last auditor and the middle auditor. We're just one piece of that puzzle. And I think it'll help a lot. We've started, I know a couple, I did a small review on sponsor, and there was a couple things. There was a review on another one. This was in Zahao. Just something small, some defensive checks that could have gone in. And so I think it's going to do a great job. Kind of excited to see where the industry goes.
But you said it's expensive, right? I imagine the average developer writing their PR for a new amendment that they proposed isn't able to do the same like you, because probably the tech, the hardware is missing, or maybe the funds are missing to do the actual review. Is this so expensive that only a few people can use it? Or is this something you think in the future maybe more people will use as well?
Yeah, so from this point of view, I think the XRPLF is going to be handling the payroll part. So like I can run a review on any PR I want. If you were developing an amendment and you wanted a review, you could ask me. I think if we add the app into the repo, then you can just do a / and you can start the process off. And I think that's great as well. I think going forward, we just have to monitor and say who's using more credits than others. But I think the idea is that if you're a prior contributor like TQ or FOMO or anyone, even Mayuka, even some of the internal devs, you can just use the overall account API key. And at the end of the month, we'll keep track of it, or the XRPLF will keep track of it. And then, if we need to shut some people down, that's fine. Or if we need to find other solutions, that's fine too. But yeah, for starters, I think it's going to be sort of, I can invite employees into the app, and that I will only invite sort of a list of developers to start.
Another question, how long does such a AI audit review take? Is it 5 minutes, 10 minutes? Is it an hour, a whole day? And take in what it accomplishes versus how long, let's say, a reviewer would need to do. What is sort of just rough estimates? You don't need to give exact numbers.
I think that last one took 15 minutes. So 15. That one on the file, 15 minutes on one file. Okay. On a single file. So when we do a group, it's a while.
A while as in an hour or something, because 15 minutes
as in could be a couple hours.
Yeah. But that's nothing, right?
Let's look at a big one. So I did consensus. The 2 consensus folders was 18 files, and it took an hour. An hour.
But that's nothing.
So not too long. Not too long.
But you have experience, of course, with reviewing amendments, codes, PRs.
Right.
How long would you take? Would you need to do the same work? Estimate?
Days. Yeah. Okay. Yeah. Because you're doing a lot of, and sort of explained it before, where you're like, okay, this function does this, and it's passing in these parameters. Okay, well, where are those from? Okay, and then you're also writing tests. You're building it. You're writing tests for it. You're sort of looking at exploits that you think you could do, or just sort of reading over the code. I would say days, depending on what kind of PR it is. Could be even more than that. I mean, some of them definitely run longer than that. Loans ran longer than that. So I don't know if it's definitely faster, but I think on some levels it's probably more exacting as well. You get your coffee, and then you sit down, and then you read some stuff, and then you get an email, and then you're like, oh, where was I? Oh, I was on here. And that's the value that's sent in. And you're like, okay, that value is validated. It's not a null. We're not dereferencing a null pointer. And then you come back, and you were looking at the wrong thing. There's so many avenues and pieces that you can make a mistake as a human being.
Right.
And AI doesn't have any of that. It doesn't get bothered. It doesn't go off course.
Right.
So those are some of the things that I think are valuable with AI.
How is it about formal specification? Because I think AI and formal specification could really help, because you have this basically perfect documented context, and then you put AI on it to audit. How do you see the future with XRPL and the verification specification going forward?
Yeah, I think excellent. I think it's an excellent idea. It reminds me a lot of skills. I don't know if we're familiar with Claude skills, but similar to that, where this is how this works. This is exactly how this works. And so AI having that knowledge definitely gives it a head start, where it knows it doesn't have to look in all these different places. But again, the thing is even if you know that this, and this happens, I was wondering the other day, with AI, if it costs 50 cents more to go and verify that this, and this happened, instead of reading it in a document, which one do you truly want? You probably want to pay more for it to go through the steps. Yeah. Even if the result is the same, you may still want to go through the steps. But it definitely will speed it up, and it's definitely valuable. And so I think it's interesting. And I think also writing specifications from it will be easier. I think writing a spec now just in general with AI will also be interesting because, again, it's still going to go through the steps and find it. But I definitely am excited to see like a formal specification and see where that leads us.
Is this your personal roadmap, security roadmap? As in, we have AI audits, we have human audits. Obviously, a human, or maybe in combination with AI, will write the PR, and then also specification, verification. Is this how the XRPL will be getting more secure over time? Because right now we are like in this middle ground where we don't have the verification right now. We don't have smart contracts. We don't have a sidechain. So how do we move forward with security in mind?
We need to survive. We need to survive.
We do. Okay. I think it's my ideas. I think a lot of other people share those ideas. I think, there's definitely some big movements in Ripple regarding AI, realizing how powerful it could be used in those things. Oh, I got another one was testing suites. So when we test things, we think of what tests to come up with, right? And then you get an auditor and he comes in and he goes, well, did you think of it like this? And that's really cool. I really was excited working with a few auditors and understanding that they think a little differently than I did. I thought I found them. They had other ideas. But one thing that we really saw with loans that was really cool was they came out and they created this huge testing document that was like all of these things could be tested. And we were like, okay, well, let's implement those. Let's write those tests. And I think that could be, I don't want to call it a saving grace, but it could be something that led to you fixing maybe a bug or two in loans that we've already fixed, there's no bugs in loans that we've already fixed, some rounding stuff that sort of came up with that. And so I think we could also use AI in that facet. So not just an AI review of the code, but a review of how your testing suite is. What are you missing any tests that we could write that could validate a position or not? But yeah, it's my road. I don't want to call it my roadmap because I know a couple other people who are very interested in these sort of ideas. But it's definitely something that I sort of hopped on really early, right away after the batch bug, and sort of in that process of like acknowledging it and then where's the solution. And I think those are some good solutions.
Yeah, and I think this is also maybe the step for the community as well to get involved. Like if you are not a developer right now, you maybe have the feeling that you have no way to get involved or to help you, for example, developing something or building something. But maybe AI is also a way to propose a new feature or to at least write a draft. Or if you have something in mind, use AI to help you write the draft in a way that other people can read in a way as it should. So templates, for example, and as you said, testing suites. And so there are many use cases. I think AI will help in the future, not just for developers, but for the average people as well. Like you. So maybe this will really move the needle in the future, not just for security, but also for people getting involved.
But that shows that there's just a lot we can do to augment.
Right.
Not only actually maybe core ledger developers, but even like validators and others who want to make their due diligence. It helps them a lot to see or have access to some of these tools, maybe even on a very basic level, or to have like at least insight into some of these reports, that are generated to see, hey, okay, cool. It went through all of these tests. There's a huge file, lots of tests covered. Am I comfortable with it or not? It just helps to build confidence. That's at the end of the day the thing, because none of these things are 100%.
True.
You get very close to the 99% or whatever you can attempt, but at the end of the day, still, of course, a confidence thing. And
true, we need confidence for the batch amendment. We also need confidence in the future for smart contracts, but also for the quantum network, which you proposed as well. There's like a whole suite of things you already worked on. Like it's nothing new. It's in the background. You are working on it. It's called AlphaNet, and it uses Dilithium cryptography. Maybe, Ovet, do you want to say something?
Just one thing, like for people listening. Look, we went from he has a sidechain for options to he built an AI agent security audit tool. Now we have a quantum alpha network that runs on algorithms that are quantum proof. Dennis is cooking. Okay, so Dennis. But yeah, tell us about the quantum one. That's sort of.
So AlphaNet is really the network where I want to put everything that I'm working on. So sort of options could go on there. Passkey could go on there. Subscriptions. There's pay channels for IOUs that I want to put on there. Anything that's sort of really getting worked on but hasn't been merged in. So we have in the XRPLD community, we have mainnet and then we have testnet. And testnet matches mainnet in amendments. And then we have DevNet, which matches what's merged in to the repo. So been reviewed and been audited. But for people who are building other things like that haven't been merged in or aren't slated on the future, I wanted a place where we could go and we could test those things. So that's what AlphaNet is. And one of the features on there is a new signing algorithm called Dilithium, which is quantum proof signatures. And that is not only mine. It is actually stemmed from a gentleman named Atharva from the Dublin University, or one of the Dublin universities, part of the UBRI program. And he originally did the work and got the crypto algorithms going and shown that you can sign and verify these cryptographic signatures. And I took it a step further in actually getting it onto a network, meaning that the validators actually use these keys. The UNL is actually signed by a Dilithium. The SDKs were updated so you can sign and submit transactions. So really just sort of pulling it a little bit more of the way, maybe not all the way, but I really wanted to see what it was like on a network, how it would work, if it would slow it down. There's definitely been some things we've figured out. One thing that was really interesting recently was that when you have a Dilithium signed smart contract, it's really big because you have the smart contract code and the signatures. And we actually maxed out a parameter for sending data, the size of the data. So we had to, I just went in and upped it. But we as developers of the XRPLD, we have to decide, how are we going to do that? What is the problem and how do we solve it? And that's sort of the reason why I do these things is I love prototyping. That's my favorite thing. And so I do it because I don't trust what I hear and what I read. I need it to be live and I need to see it in action. And then I want to go through the logs and see what's happening and how do we actually solve these problems? Because when you in business or just in life, you like have something and you think this is what's going to happen, or you think these are the problems that you're going to get. But then you get there and you're like, all these other problems that you had no idea what they were, or if they existed, start to come up. And you're like, well, why didn't we think about this? And it's like, well, I guess maybe there was something online that we could have read. But when you put yourself in it, it's hard to ignore. So that's sort of the reasoning by putting these things as fast forward.
You know, Dennis, like, this is really spot on, because one of the things that I've always heard is like, hey, these signatures are huge, you know, with the current quantum proof algorithms that are out there compared to what we have currently. And when I was using your quantum network there, XRPL enabled network, I could see it side by side, because I did one on the testnet and I did one on yours, and I could see like the signature, how like the difference. One was like basically one liner, the other one was like so huge. I was like, I can see now basically live what I've just read in theory about how it would work for the XRP Ledger.
Or you see a number and you're like, I don't know what that number is. 64 versus 1,000. And you can kind of get there. But yeah, when you put it next to each other, you're like, oh, wow, okay, this could be a problem.
Exactly. Yeah.
Do we even have a problem? Are we in danger? Like, is this an issue we need to solve this year, or is this just far in the future?
NIST says we have till 2030. I don't know if there is a pressing problem. I don't know if you're ever going to know. Why would you tell anybody? I mean, if you broke, EDSA or SECP, why would you wouldn't really tell anyone. So how long after that period is there? I don't really know. I just saw it. Somebody else was working on it, and I thought, I'll take this across the line.
The interesting thing with this is eventually we will get there, maybe 10, 20, 30 years, like eventually at some point we will get there. Might take like forever. And the interesting thing is with that is you have like the algorithms that Dennis was using already that are available, but the tricky thing is you want sort of to wait as long as possible without implementing, to wait maybe there are going to be better algorithms in the future.
Right.
So you sort of, it's like this situation where you don't want to be too late, where it's like already there, but you don't want to be too early and then take like maybe too immature algorithms or something like this that could have been like better in the future. So it's like this sort of, very hot middle ground that you need to evaluate. When are you going to implement? It shouldn't be too early, but shouldn't be too late. So that's
exactly.
That's
it takes time to validate as well. If this is what you are building right now is even the right way forward. Well, like you are currently building on Dilithium, but maybe Dilithium is not the right way forward. Maybe in half a year or in a year we will find out, well, it's completely different algorithm that works way better. And you have all the prototype done on a completely wrong algorithm that gets replaced in the future. Could happen.
That's why so many blockchains are not yet like completely switching to, let's say, quantum or something like this, because there might be something better in the future, and there is no risk right now. So that's sort of the. But you should think about it. That's the thing. You should think about it. And plus, like this is Dennis went with the algorithm route, which I think is like, I would say that typically the best like full encompassing solution. But there's also a proposal by Dennis, which doesn't introduce like any new algorithm. It's basically just a more easier way to key rotate. Like you basically just constantly key rotate after each transaction, so that you are basically always on an address that hasn't submitted a signature to the blockchain, and thus you are sort of safe. Yeah, it's just also an interesting way to handle a specific.
Yeah, it works. I don't know if I would call it a solution. I mean, it's a solution, but
it's a workaround.
That's why I called yours a full encompassing one.
Right.
There are trade-offs, right? Like introducing, because why are we not doing it right now? Because we're introducing big signatures, like everything will get blown up. So what kind of big trade-offs, excluding the obvious one that everything just gets bigger, are there? What except this one? Why are we not doing it right now, except for the obvious one, which is we don't know if the algorithm is right. We don't know if we really want to blow up the ledger right now. Something else?
I think it would be the ledger blow. No, I think it's the size of it would for full history it'd create a lot of data to store those huge signatures. The other thing is we may even be able to, they're uncompressed signatures and public keys, and we can compress them if we want to, so we can make them smaller. But that's a decision that has to be made, right? And I didn't want to make that decision, so I left everything as is uncompressed. So it's also a signing algorithm's a big deal. I actually think we should have passkey before we have quantum. But even with passkey, it's like, there's pushback of just like, well, this is, it's a security thing. Do we really want to add another signing algorithm in the flow of this? I mean, right now it sounds like suicide. So, I don't know if you could get anyone to agree that right now we should add another signing algorithm after
probably not, right?
Batch and some other issues that have occurred. So that's, probably some pushback. I think Vet nailed it. You don't want to be too early. I think that's why it works great as a prototype. If you're maybe, on the Ripple team or on the XRPLF team and you need to look at quantum and you need to like prepare us for quantum, you've got this prototype chain. You've got it running. You want to check it out. You want to check out signatures and validations. The other big one is upgrading the validator set. Each validator will have to go down one at a time and come back up as a quantum validator. And so that is, that's an interesting, first the network has to update, then they do that. And that's an interesting sort of where you have to sort of like play it out first. And you're like, then you go, and then you go, and then you go, and maybe do it on a test network. And like, so that's probably a big worry, bigger than just being able to sign a transaction. But can we update that validator set to be quantum proof seamlessly? And what even does it look like? Do we have contingencies to roll back? Those sorts of things are really why it's a prototype right now.
Yeah.
instead of waiting.
What about TPS and speed and validation time? Would this be lower? I think it will slow down, right? Maybe?
The bigger signatures don't need more time to sign. No, because the data's in there, because it's uncompressed.
Okay.
They're actually faster. They're faster than ED slightly, which is definitely faster than SCCP. So we're not going to get a downgrade in the validation of a signature. Where the downgrade will come from is transferring data at speed, right? Large amounts of data. It's slower, and then you have more nodes that you have to go to, so naturally it's slower. But there are some cool advancements. Tesla came out with one, so did China, where they were able to get data to go from one place to another in very high speeds, like downloading a movie in less than a second. I think it was 900 terabytes in an hour.
Wow.
Or petabytes or something. It was extremely impressive. So, what's interesting is like how the society, I guess life works is like, we're coming up with this quantum stuff and the signatures are going to be heavier, which means we're going to have to transfer more data, which is going to slow it down. But then there's advancements on the data speed that we can transfer. It's like everything just sort of falls into place. It's kind of interesting that sort of happens in line with each other. I guess it's more like you have a new problem that needs a solution. And so people then put their brain power towards, well, what's the solution to transfer data on a protocol faster? And they're like, okay, well, let's work on that for a while. And then they come up with a better solution.
So maybe this is also why we still are prototyping right now. This is also maybe why we still need to wait a little bit. Because if we rush something right now and we don't have the solution to the upcoming problem that we don't even know about right now, we cannot solve the really pressing issues that come up, and then we are stuck with what we agreed on.
Right.
And then maybe the XRPL will have downsides where we don't have a solution for right now.
Sure.
So maybe, as you say, prototyping right now, trying to build sidechains, trying to really prove to the network and to the community that what you think should be added to the future is actually working and has solutions to downsides that will come up. So I think this is really the way forward, especially also with the sidechain, with the options sidechain, just trying out stuff before we get smart contracts, before we get zero knowledge and can do layer 2s and so on. Just the sidechain part alone, I think, is a good start. Also, maybe to prove that prototyping something is actually viable, because right now there's no one did it before. Really, we would only have the XRPL EVM sidechain, but I don't think I wouldn't say it's for prototyping. It's actually a worthy chain for deploying EVM smart contracts. So using it for maybe exploiting it for prototyping is not the way forward.
Right.
So on this, I thank you, Dennis. Thank you, Ved, for joining. We should definitely do it again in the future when the quantum network is ready, like really practically ready, and the sidechain goes live. People will maybe developing for you, and you come up with solutions to your problems. And hope to see you again. And thanks everyone for listening.
Well, thank you for having me.
Perfect. Thank you. Ciao, ciao.
Bye.